welcome back. Today we're going to be doing factoring with special cases. Kind of a shortcut for you, but speaking of special, look at these guys. That's right, we got not Hello Kitty, that's Wolver Kelly. And we have Brus Klops, and of course, Professor Bean. Not the X-Men, but the Math Men, the M-Men, or the Men. Whatever it is. Honestly, I really just wanted to have to use this picture of Kelly again because he looks like Wolverine with these lamb chops or whatever these things are. Alright, let's take a look here. Multiply. Let's do a couple of multiply things now. First thing I want you to notice is these are special. It's the exact same polynomials I'm multiplying. The only difference is that one's a minus and one's a plus. Let's see what happens. Double distribute. G times G is G squared. G times 5. 5g, negative 5 times g, negative 5g, and negative 5 times 5 is negative 25. What happens here in the middle? These cancel and we're left with g squared minus 25. Same situation here. We have the exact same thing over here, just positive and negative. So 2x times 2x is 4x squared. 2x times 3 is 6x. Negative 3 times 2x, that's negative 6x. Negative 3 times 3 is negative 9. And again, these middle terms cancel out. So we're left with 4x squared minus 9. So let's come down here and factor in how we know how to. All right, so we need two numbers that multiplied a times c. B, in this case, our middle term is 0, right? So we want something to add to 0. 1 times negative 16. I need to multiply to negative 16 and add to 0. That, of course, would be 4 and negative 4. Interesting. All right. Down here, I need two numbers to multiply to 4 times negative 36 and add to, again, 0. Well, that's 6 and negative 6, so 4y plus 6 and 4y minus 6. And I can factor a 2 out here, right? So I'm going to take a 2 out, and I have 2y plus 3. And I can take a 2 out here, that's 2y minus 3. All right, hopefully you can kind of see a pattern here. A couple of things are emerging. Every time we have this situation where there's no b term and there's a subtraction in the middle, it's pretty easy to factor it. I get the same exact thing except for positive and negative. Now, how do I know what I'm going to get? Well, that leads to the first special case, and it's called the difference of squares. The difference of squares is because the first term is a perfect square and the last term is a perfect square, and difference because we're subtracting it. If we were adding this, we couldn't do this rule. All right? But if I have this situation where I have a perfect square, remember, perfect squares, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Those are the first 12. If I have a perfect square in these situations, I can do this rule. And what happens is that I take the square root of the first one, I get A. I take the square root of the second one, I get B. I put them down here, and it's just positive and negative. Let's take a look. So I have minus, so that's difference. Is v squared a square? Yeah, I can take the square root of v squared. That gets me v. Put that in the front and the back. Square root of 81. Square root of 81 is 9. Front and back. One's minus, one's plus. It really doesn't matter. Couldn't make it any easier, could I? Is 36k squared perfect? Sure is. That's 6k. So I put it in the front, put it in the back. Square root of 121, that's 11. 11 in the front, 11 in the back, one's plus, one's minus. Again, you need to make sure that you have minus in between. That's why it's called the difference, and they're difference of squares. We'll get to them in a second where it's going to look like difference of squares sometimes, but you may have to take out a greatest common factor, all right? All right, let's try another one. We have this one, g minus 5 squared. So I want to take the same thing and multiply it by itself. G minus 5 times g minus 5. That's g times g is g squared. G times negative 5 is negative 5g. Negative 5 times g is negative 5g. Negative 5 times negative 5 is a positive 25. And in the middle, negative, now they don't cancel, so I have g squared minus 10g plus 25. All right. Same thing over here. I'm going to multiply it by itself. 2x plus 3 times 2x plus 3. 2x times 2x is 4x squared. 2x times 3 is 6x. 3 times 2x is 6x. 3 times 3 is 9. Combine the middle ones, so we have 4x squared plus 12x plus 9. So let's go down here and factor them. See if we can figure out a trick. So I need two numbers that multiply to 16 and add to negative 8. Well, negative 4 and negative 4. So b minus 4 times b minus 4. Perfectly good answer, but really let's be honest with ourselves. Anytime you have the same thing multiplied by itself, it's better mathematically to start writing this out. B minus 4 squared. This tells me you can do the factoring. This tells me you understand a little bit more about math. And this is something you want to get to, all right? Over here, 4 times 9 is 36, and we want to add it up to positive 12. Again, that's 6, so 4y plus 6 times 4y plus 6. 4 times, we're taking out common factor of 2 here, so it's going to be 2y plus 3. 2y plus 3, and again, that's good, but I need to understand that that is 2y plus 3 squared. All right, let's see, is there any patterns emerging here? Well, the first thing you probably look at and see is that, again, first and last things, all these are perfect squares, right? 4, 9, 1, and 16, they're all perfect squares, so that's going to be another key here. But how do we get to 10? All right, how do I get to 10? Well, if you look in here, I just double that middle term, right? Essentially, I'm doubling whatever is in here to get to 10. I doubled 6 and 6 to get 12. The question is how? Well, if you really look at it, 2 times 3 is 6. And then we double that to get 12. So I take multiply, and I got that. All right, going backwards, how do I get 12? How do I get down here? Well, let's see. It was double that, so half of that is 6, right? How do I get 6 from 4 and 9? Well, again, square root of 4 is 2. Square root of 9 is 3. 2 times 3 is 6. All right? So this leads to our next rule, the perfect square trinomial. All right, and this should say a squared. So a squared plus 2ab plus b squared equals a plus b times a plus b, or a plus b squared. In other words, if I have a perfect square and a perfect square, and when I square root those, add them together and double it, I get the middle term. Then I can get my answer. Same thing down here. The difference is that this is a minus, all right? Plus is always at the end. Let's take a look. Why is plus always at the end? Well, here's a minus. Negative times a negative is a positive. Positive times a positive is a positive. So that last term is always going to be a positive. This term tells us whether inside is minus or inside is plus. So let's come over here. The first thing I need to look, is this square root, perfect square? Yeah, that's x. Square root of this one is 10. So this is like 1, right? 1 times 10 is 10. I have to double it. 10 times 2 is 20. This works, so I know my answer is x and 10. And this is a positive, so this is a positive squared. Okay? Over here. Is this a perfect square? Yep. 5, perfect square 6. Let's see, 5 times 6 is 30. Double it is 60. So this works. So 5x and 6. And then what's our middle sign? Minus. All right. Again, tricks just to figure out how to do this. They're much faster when you see this. It's a much better way to do these whenever you have this special case. Let's try these 3 here. First thing I know, is 32 a perfect square? No. Is 2 a perfect square? No. Maybe we're going to have to do this the old-fashioned way. Or, well, let's see. There is a greatest common factor of 2, right? So I'm going to take a 2 out. 32 divided by 2 is 16p squared. 16 divided by 2 is 8p. and 2 divided by 2 is 1. Now let's take a look. 16, the square root of 16 is 4, square root of 1 is 1, 4 times 1 is 4, and double it, and we get 8. So we have our situation here. So I have 4p at the front, 1 at the back. I know I'm multiplying by itself, so it's going to be squared, and it's a positive because this is plus. How much faster is that? When it works, it's a great trick. Let's go over here. 12 is not perfect, 75 is not perfect. And I notice there's an extra r here too, so I'm going to take that common factor out. I know 3 goes into 12 and the 3 goes into 75. So I'm going to take 3 out, and I got 4. I took an r away. Minus 25 divided by 3, or 75 divided by 3 is 25, excuse me, and I took that r away. Perfect square, and this is a difference of squares, so I'm going to use my difference of squares formula. That means 2r minus 5 and 2r plus 5. All right? It's kind of funny because the shorter one to begin with, the difference of square, ends up being a longer answer, whereas a perfect square trinomial is longer to begin with, ends up shorter. Let's take a look at the last one. Is p squared perfect? Yeah, the square root's 1. Square root of 225 is 15. 1 times 15 is 15. Double it, 30. It works. So p and 15. And I know this is a minus, so this is going to be minus. Perfect. Just like that. And now this works just the same way as we've done the other time, solving and sketching. So let's get this equal to 0. So now we have 4x squared minus 28x plus 49 equals 0. Let's check it. Square root of 4 is 2, and the square root of 49 is 7. 2 times 7 is 14, times 2 is 28, so it works. So we get 2x minus 7 squared equals 0. Now normally I would write 2x minus 7 equals 0 and 2x minus 7 equals 0, right? It's the same thing. I'm only going to do it once here. So add 7 to both sides, divide by 2, and x equals 7 halves. Let's do a sketch over here. 7 halves is 3 1/2, so 1, 2, 3, 4, and we're at 3 1/2. Perfect square trinomial is always going to have one point, and it's going to end up on the x-axis. All right? Come down here, find the zeros. So 0 equals x squared minus 64. We got two perfect squares. The difference of squares, x minus 8 and x plus 8. Now this time I have two different answers. Some of you probably can do this in your head right now, and I can too. Plus 8, this is going to give you x is 8 minus 8. This is going to give you negative 8. Sketch it. We got negative 8. We got positive 8. We got a big parabola. All right? So pause the video for a second and you try these. All right, so let's take a look here. First thing we need to do here is take a greatest common factor out. We always look for greatest common factor first. So that's x squared plus 6x plus 5. Perfect square, yes. Not a perfect square, so we have to do it old school. 1 times 5, I need two numbers that multiply to 5 and add to 6. So that is going to be, I put an x in the front, put an x in the back. 2 times 3, well, that won't work. 2 times 3 is 6. We want to add to 5. So 5 times 1. 5 times 1 is 5. 5 plus 1 is 6. There you have it. Number 2, perfect square. Yep, perfect square. Square root is 7. Square root's 5. 5 times 7, 35. Double it, 70. So this is a perfect square trinomial. So the square root of the front, the square root of the back, it's positive because this sign's positive, and we square it. All right, down here, factor, we have a perfect square and a perfect square. It's minus, so that's difference of squares. So one's minus, one's plus. That way we cancel out the middle term. 3x in the front, 2 in the back equals 0. So we have 3x minus 2 equals 0. Add 2, we get 3x equals 2. X equals 2/3, and of course it's going to equal negative 2/3 as well. Let's take a look and sketch it. So if this is 1 and negative 1, we're going to be about here and here. and it's a parabola. All right, there you have it. I'm going to leave you with my favorite group of guys. See you on the flip side.
Sit down, we want to talk to you.
Am I in trouble? Did my mother call you?
Just sit.
We think we can help you with your stage fright.
Oh, I doubt that. I haven't figured out a way, and I'm much smarter than all of you.
Yes, but you're not smarter than all of us put together.
Oh, I'm sorry. That is what I meant.
Okay, your problem is you're trying to do this all by yourself.
We can help you. We can be your team, like Professor Xavier and his X-Men.
I do like the X-Men.
Did I see X-Men?
Yeah, we watched it last week. You said you liked it.
Oh, I say a lot of things, sweetie. So, how about it, Sheldon?
I don't know. If you're my X-Men, what are your powers?
Okay, well, I'm gonna take you shopping, get you a nice suit. Might give you more confidence.
It's not exactly a mutation that would get you into Xavier's School for Gifted Youngsters, but go on. Leonard?
I thought I could try to analyze you and get to the root of your anxiety.
What qualifies you to attempt to understand my mind?
My mother is a highly regarded psychiatrist, and I've been in therapy ever since she accused me of breastfeeding codependently.
Raj says he can teach you... What did you call it? I don't know, some Indian meditation crap.